Welcome to another deep dive. This time, we're tackling something that might sound a little bit intimidating at first glance. Cognitive load theory.
Oh, yeah.
But I promise it's way more interesting than it might initially sound.
It really is.
And as always, I've got an expert here with me today to help us unpack it all.
Absolutely.
So before we get too far, tell everyone just a little bit about yourself and what you do.
Sure. So, I'm a researcher specializing in cognitive psychology with a particular focus on learning and instruction. My work delves into how people process information, especially in educational settings, and how we can optimize that process
Okay.
for better learning outcomes.
Yeah, and that's exactly what we're going to be talking about today.
Yeah.
Now, for this deep dive, we're looking at two sources. One's an academic paper by a leading expert in cognitive load theory,
Right?
and the other one is an article about applying CLT in a field that I think a lot of people would agree is, well, kind of known for being tough to learn,
Yeah.
accounting. So before we dive into the nitty-gritty, I think it would be helpful to start with the basics.
Sure.
So, when we talk about learning, are all types of knowledge created equal? Like, is learning a language the same as learning, advanced calculus?
That's a great question, and the answer is not really. Humans are uniquely good at acquiring two types of knowledge. The first type, which is like learning a language as a child, is what we call biologically primary information.
Okay.
And it's almost like it's pre-programmed. We're wired to pick it up naturally without too much conscious effort.
It's like we're just hardwired to soak it up.
Right.
So that's the easy stuff, I guess. But what about all the things that we're not wired to learn automatically? Like all that knowledge that's so important for school or for work or just for navigating this increasingly complex world.
Right, exactly. And that's what we call biologically secondary information. And this is where things get a little bit more tricky because this type of knowledge requires a lot more conscious effort and even more importantly, good instruction. It doesn't come naturally.
Yeah.
We really have to work at it.
Well, this is really interesting. So let's talk a little bit more about the mechanics of all of this. Like when we're trying to learn something new,
Yeah.
where does all this information actually go in our brains? Is it just piling up somewhere waiting to be retrieved?
Well, you can think of it like this. Your brain has this sort of mental scratch pad. We call it working memory.
Okay.
And it's kind of like a whiteboard. It's where you hold the information that you're actively thinking about or working with at any given moment.
Oh, okay. So that's where it all goes when we're trying to process something.
Exactly. But here's the catch. Working memory is very limited in both capacity and duration.
Okay. So like how much can it hold?
Well, researchers believe that it can only hold about 5 to 9 chunks of new information at a time. And if we don't do something with that information fairly quickly, it's gone, it fades away.
Just like erasing the whiteboard.
Exactly.
Yeah.
So, if we want to remember something for the long haul, we have to transfer it from working memory to a more permanent storage system.
Got it. So where does all that information go when it's not on that mental whiteboard anymore?
That's where long-term memory comes in. And this is really like the vast warehouse of your brain.
Okay.
It's essentially unlimited in capacity, and it's where we want to store all of those important facts, skills, and experiences. The challenge is getting the information from that tiny whiteboard of working memory into this vast warehouse of long-term memory. And that's where schemas come in.
Okay, schemas. What are schemas? I feel like we've hit on one of those real key terms here.
Absolutely. You can think of schemas as like mental filing cabinets. They organize related information into meaningful categories.
So it's not just random bits of data floating around.
Exactly. Schemas help us make sense of new information by connecting it to what we already know.
Ah, okay.
They're like mental frameworks that we use to understand and interact with the world.
So the more organized those cabinets are, I guess the easier it is to retrieve what we need, right?
Exactly. And this is actually where things can go wrong because sometimes we try to cram too much information onto that tiny whiteboard of working memory. And this leads to what we call cognitive overload.
Ah, I was wondering when we were going to get to that feeling of just like your brain is fried.
Yes. And it's a major obstacle to learning because when our working memory gets overwhelmed, we just can't process information effectively.
Right. It's like trying to stuff an overflowing suitcase. It just won't close properly.
Exactly. And understanding cognitive overload is really at the heart of cognitive load theory.
So this overload is like the enemy of effective learning then?
It is. And to understand how to manage it, we need to break down cognitive load into three different types. Now, the first one, we call it intrinsic cognitive load. And it's essentially the inherent difficulty of the material itself.
Okay, so some things are just naturally more challenging to learn than others.
Exactly. Like, for example, understanding rocket science is probably going to have a much higher intrinsic load than learning the alphabet.
Oh, I've
It's
got
just
it.
more complex.
Yeah.
And that's okay. We can't really change the intrinsic load, but we can manage it by understanding the other two types of cognitive load.
Okay, well, let's talk about those other types of cognitive load then.
Okay.
What are they?
So the second type is what we call extraneous cognitive load. And this is kind of like the bad kind of load because it comes from things that are external to the material itself.
What do you mean, like bad teaching?
Well, yeah, that could be one example. Like, imagine you're trying to learn from a really poorly designed PowerPoint presentation
Right.
where the slides are just crammed with text and cluttered images.
We've all been there.
Right. That visual chaos
Yeah.
is adding extraneous cognitive load. It's making your working memory work harder than it needs to just to try to filter out the noise and focus on the essential information.
So it's not about the complexity of the information itself, but the way it's presented.
Exactly. And another classic example of extraneous cognitive load is when you're trying to learn from a diagram and the explanatory text is located somewhere else, like on a different page or even in a completely different section of the textbook.
Yeah, you're like flipping back and forth.
Yes. So instead of the information being presented in a clear, integrated way, you're forced to do all this extra mental work just to connect the dots. And that can be incredibly frustrating.
I could see that. It's like trying to follow a recipe when all the ingredients are scattered all over the kitchen.
Exactly. So minimizing extraneous cognitive load is really about streamlining the learning process, making sure that the information is presented in a way that's clear, concise, and easy for working memory to handle.
I like it. Okay, so that's extraneous cognitive load, the bad one. What about the third type?
So the third type is what we call germane cognitive load. And this is the good kind of load.
A good cognitive load. Okay, I'm intrigued. Explain that one.
Germane load is the mental effort that you put into actually making sense of new information. So it's about building those schemas, making connections between new knowledge and what you already know.
So it's about depth of processing.
Exactly. It's about engaging with the material in a meaningful way that leads to deeper understanding and better retention. So the goal of good instructional design is really to minimize extraneous cognitive load and maximize germane cognitive load.
So we want to clear the clutter and make space for that good, deep thinking.
Exactly.
I like it. So this is all very theoretical, but are there any studies or research that actually back this up?
Oh, tons. Cognitive load theory is backed by a wealth of research, and one really fascinating example is something called the worked example effect.
Wow.
And basically, what studies have shown is that when you're learning something new, studying worked out problems is actually more effective than trying to solve them yourself from scratch, especially when you're a beginner.
Wait, really? That seems counterintuitive. Like, don't we learn best by actually doing the work ourselves?
That's what a lot of people think, but think of it this way. Imagine you're trying to assemble a piece of furniture and you have absolutely no instructions.
Okay.
You could just start putting pieces together randomly, but chances are you'd probably end up feeling frustrated
Right then.
and confused.
Right.
And the end result might not be what you hoped for. But if you had a step-by-step guide showing you exactly how it's done, you'd be much more likely to succeed, right?
Absolutely. Those instructions make a world of difference.
Exactly. And that's what worked examples do. They provide that step-by-step roadmap that reduces cognitive load and allows you to focus on understanding the process without getting bogged down
Hey.
in the complexities of problem solving right from the start.
So they kind of give you a little peek behind the curtain?
Exactly. They reduce that extraneous load by showing you how the experts do it. And as you become more comfortable with the material, you can gradually transition to solving problems on your own.
So it's like training wheels for your brain.
I love that analogy. And this actually brings us to another important concept, the expertise reversal effect.
Ooh. Okay, tell me about this one.
So, the expertise reversal effect basically states that what works for beginners might not work for experts. That support that was so helpful early on can actually become redundant and even hinder learning as you gain more knowledge. So just like you wouldn't want to keep those training wheels on your bike forever,
Right.
at some point you need to take them off to really master writing.
Makes total sense.
Right. And it's the same with learning. As you become more expert, you need different kinds of challenges,
Yeah.
different types of instruction.
Yeah, you need to keep pushing yourself.
Exactly.
Okay, I'm starting to see how all of these pieces of CLT are fitting together.
Yeah.
Now let's see how this all actually plays out in a real-world scenario.
Okay.
Because our second source for this deep dive takes us into the world of accounting education,
Right.
which, as we mentioned before, is a field that a lot of people find challenging.
It is.
Now, this article examines how instructors are using CLT to help students understand those tricky financial concepts. So what does that look like? Are they having students meditate to reduce cognitive load?
Not quite. But, it is an interesting thought.
Yeah, maybe we'll explore that in a future episode.
Right.
But for now, this article lays out 3 key guidelines for applying CLT in accounting education. All right. Guideline number 1, hit me with it.
Okay, guideline number 1, minimize split attention.
Okay, right. So less of that mental juggling act that we were talking about.
Exactly. And it turns out that accounting textbooks are often major culprits when it comes to splitting attention.
Really? How so?
Well, they often present information in a way that forces students to constantly jump back and forth
Oh, okay.
between different sources.
So give me an example.
Well, think about those diagrams that explain things like the accounting equation or how to record different types of transactions. Often, the explanatory text is placed way far away from the diagram.
Oh, yeah, like on a different page or something.
Exactly, forcing students to keep looking back and forth to try to make sense of it all.
So instead of having the information presented in a clear, integrated way,
Right.
they're having to do all this extra mental work just to connect the dots.
Exactly, and that extra extraneous cognitive load can really hinder their understanding. This article actually gives a really great example showing how a traditional textbook layout with all this split attention compares to a redesigned layout that integrates the text and diagrams more effectively.
Oh, interesting. So it's a pretty simple design change, but I bet it makes a huge difference for the students.
It does, and it really highlights the power of thoughtful instructional design. Even small changes can have a big impact
Absolutely.
on how effectively people learn.
Okay, so minimizing split attention, that's guideline number 1. What about guideline number 2?
All right, guideline number 2 is all about tailoring instruction to
Yeah.
the learner's level of expertise.
Right, because as we were talking about before with the whole expertise reversal effect, what works for beginners might not work for more advanced learners.
Exactly. And this guideline emphasizes recognizing that different levels of accounting students will have different levels of prior knowledge
Okay, good.
and schema development.
So, like a novice learner might need more support and more guidance,
Right.
while someone who's more experienced would benefit from more challenging tasks that really require them to apply that knowledge in new ways.
Precisely. And this can be applied in so many ways. Like, for example, the article talks about using simulations in accounting education.
Oh, interesting.
For a novice learner,
Yeah.
being thrown into a complex simulation with lots of moving parts might be super overwhelming and lead to cognitive overload.
Right, it's like asking someone who's just learning to drive to navigate rush hour traffic in a new city.
Exactly.
It's a recipe for disaster.
But for a more experienced learner, that same simulation could provide a really valuable opportunity to apply their skills and deepen their understanding.
So it's all about finding that sweet spot, that level of challenge
Right.
that pushes the learner
Yeah.
without overwhelming them.
Exactly. And that's one of the areas where technology can really shine.
Yeah, how so?
Well, e-learning platforms can be designed to adapt to the learner's individual level of expertise,
Oh, wow.
providing that personalized instruction and scaffolding that supports them as they progress.
That's pretty cool.
It is. It means we can move away from that one-size-fits-all approach to teaching and create learning experiences that are truly tailored to each student's needs.
I love that. So even without fancy technology, this guideline is really just about encouraging teachers to be mindful of where their students are at
Right.
and to adjust their instruction accordingly.
Exactly.
Awesome. So we've got 2 guidelines down.
Yeah.
What's the final tip for applying CLT in this setting?
All right, guideline number 3 might seem a little counterintuitive at first, but it's all about minimizing problem-solving exercises and utilizing more worked examples.
Hold on, didn't we just talk about how learning by doing is so important?
We did, but remember, for novice learners, the cognitive load of trying to solve complex problems, while simultaneously trying to learn the underlying concepts, can be just way too much.
Yeah, okay, I see the logic there.
Right, so worked examples provide that scaffolding, that
Yeah.
roadmap that helps them understand the process without getting bogged down in the complexities of problem solving too early on.
So it's not that we're abandoning problem solving altogether, but it's about using those worked examples strategically to build a solid foundation of understanding first.
Exactly. And this article cites several studies that have shown just how effective this can be in accounting education. Worked examples can significantly reduce cognitive load and improve students' understanding
That's a
of
great.
those core concepts.
It seems like a common thread running through all three of these guidelines
Yeah,
is this idea of providing the right amount of support at the right time. Like
absolutely.
we're scaffolding that learning process to reduce that extraneous cognitive load and really maximize those opportunities
Yes.
for germane cognitive load, that deeper, more meaningful learning.
Exactly. And that's really the beauty of CLT.
Yeah.
It gives us a framework for understanding how to do that effectively. It's not just about intuition or
Yeah.
trial and error. It's about grounding our instructional design decisions in what we know about how the brain works.
I like it. So we're not just throwing things at the wall and hoping they stick.
Right.
We're actually being intentional and thoughtful about how we're presenting information.
Exactly.
Okay, this has been a fascinating look at cognitive load theory
It does-
and its implications for learning.
It really is a fascinating field.
Now, I know we've only just scratched the surface here, so in the next part of this deep dive,
Yeah.
we're going to explore some even more specific examples of how to apply these principles in different learning contexts.
Looking forward to it.
Me too.
Uh,
So stay tuned, everyone.
So, we've talked about how understanding cognitive load can really transform the way we approach learning and teaching, but like you said, we've only scratched the surface.
Yeah, I'm ready to dig a little deeper.
Let's do it.
So where do we go from here?
Well, I think a good place to start is by looking at some more specific examples
Okay.
of how to actually apply these principles of CLT in different learning contexts.
Great.
Because, it's one thing to understand the theory,
Yeah.
but it's another thing altogether to put it into practice.
Absolutely. So let's get practical. Give me an example.
Okay, so let's say you're trying to learn a new software program.
All right, I've been there.
Right, we've all been there. Now, if you were to just open up the software
Yeah.
and start clicking around randomly, chances are you probably feel pretty overwhelmed pretty quickly.
Yeah, that's my usual approach, and it never ends well.
Right. And that's because you're essentially bombarding your working memory with all this new information.
Too many buttons, too many menus, too much going on.
Exactly. It's like trying to drink from a fire hose.
Oh, yeah.
It's just too much to process all at once.
Right.
So how can we apply CLT to make this learning experience better?
I'm all ears.
Okay, well, first, we need to minimize that extraneous cognitive load.
Okay, so less clicking around aimlessly.
Right. So instead of trying to figure everything out on your own, you might start by following a structured tutorial
Okay.
that breaks down the learning process into manageable chunks.
Bite-sized pieces.
Exactly. And each step of the tutorial would focus on just one or two key concepts or features.
So you're not overloading your mental whiteboard.
And ideally, the tutorial would use a combination of clear explanations, visuals, and maybe even interactive exercises
Okay.
to help you really solidify your understanding.
Right.
Another really important principle to keep in mind here is the modality effect.
Okay, modality effect. What's that?
Well, it's the idea that we learn better when we're presented with information,
Okay.
multiple modalities.
Okay.
So instead of just reading text on a screen, it's much more effective to hear someone explaining the concept while they're demonstrating it visually.
Interesting. So like combining audio and visual elements?
Exactly.
Yeah.
Because this helps to reduce that cognitive load on working memory by engaging different parts of the brain.
Ah, so you're not putting all your eggs in one basket, so to speak.
Precisely. Now, once you've got a good foundation in the basics, that's when you can start to gradually increase the challenge
Okay.
by moving on to more complex tasks or problems.
And that's where we start to really tap into that germane cognitive load, right?
Exactly. And as you become more expert in using the software, you can start to explore new features.
Yeah.
Experiment with different approaches and really push the boundaries of what you can do. But it's all about that gradual progression,
Yeah.
starting with those strong foundations.
It makes sense. So let's say we're not talking about learning a software program. Let's say we're talking about something like learning a new language. How would we apply CLT in that context?
Well, similar principles apply. So one common mistake that language learners make is trying to memorize long lists of vocabulary words in isolation.
Oh, yeah, the dreaded flashcard marathon.
Exactly. And while memorization can be helpful to a certain extent,
Right.
it's not very effective for long-term learning.
Because you're not really connecting those words to any kind of meaning or context.
Exactly. And that's where CLT comes in. So Instead of just memorizing words out of context, a
Hmm.
more effective approach would be to learn new vocabulary within the context of meaningful phrases or sentences.
So you're building those schemas, those connections.
Right. So, for example, instead of just memorizing the word gato,
Okay, that's cat, right?
yes, cat in Spanish, instead of just memorizing that word,
Yeah.
you might learn the phrase, El gato está en la mesa.
Okay, so that's the cat is on the table.
Exactly. So now you're not just learning the word,
Yeah.
you're also learning its grammatical function
Yeah.
and how it relates to other words in a sentence.
So it's all about making those connections and understanding how the pieces fit together.
Precisely. And another really important aspect of language learning is, of course, pronunciation. Now, if you're just listening to audio recordings and trying to imitate the sounds without any visual feedback,
Okay.
you're likely to make a lot of mistakes.
Yeah.
And it's going to be harder to correct them.
Right.
So a much more effective approach would be to use videos
Okay.
where you can actually see how the speaker is forming the sounds.
So you can see how their mouth is moving, how their tongue is positioned, all that good stuff.
Exactly. And this is where that modality effect really comes into play again. You're getting both auditory and visual input,
Right.
which helps to reduce cognitive load and improve learning.
This is making me think about how we learn all sorts of things, not just languages or software programs. Like, think about learning a new sport or a musical instrument. It's all about breaking down the complex skills into manageable steps, providing the right kind of support and feedback, and gradually increasing the challenge.
Absolutely. And CLT gives us that framework for understanding how to do that effectively.
It's like a blueprint for effective learning.
Ex-
Now, I know we've been focusing on individual learning here, but are there any implications of CLT for things like group learning or classroom settings?
Oh, absolutely. In fact, CLT has a lot to say about how to design effective instruction for groups.
Well, let's unpack that then. How can we apply these principles in a classroom setting?
So one of the key implications of CLT for classroom instruction is the importance of reducing extraneous cognitive load by creating a well-structured and organized learning environment.
Okay, so that means decluttering the classroom, both physically and mentally.
Exactly. So that might involve things like minimizing distractions, presenting information in a clear and concise way,
Yeah.
and using visuals and other multimedia elements strategically.
So it's about creating a space where students can really focus on the learning.
Exactly. And another important aspect is providing clear learning objectives and making sure that students understand what they're expected to learn.
Right, so everyone's on the same page.
Exactly. Because when students know what they're supposed to be learning, they can direct their attention more effectively.
And that reduces cognitive load.
Precisely. Now, another really important consideration for classroom instruction is the idea of scaffolding.
Okay, we talked about this a little bit earlier, but how does that apply in a group setting?
Well, scaffolding is essentially about providing temporary support to help students learn new concepts or skills.
So it's about breaking down those complex tasks into smaller, more manageable steps.
Exactly. And that might involve things like providing worked examples, modeling the process, or offering hints and guidance as students work through problems.
Okay.
And as students become more proficient, the scaffolding can be gradually removed.
So they're slowly gaining independence.
Exactly. Now, another really powerful way to apply CLT in the classroom is through collaborative learning activities.
Oh, interesting. How does that tie in?
Well, when students work together in groups, they can share their cognitive load, they can help each other process information, solve problems, and make connections.
Yeah, it's like they're each contributing a piece of the puzzle.
Exactly. And this can be a really effective way to promote deeper learning and understanding.
So CLT is not just about individual learning. It's about creating a learning environment that supports collaboration and shared understanding.
Absolutely. And when we design instruction with these principles in mind, we can create truly engaging and effective learning experiences for all students.
I love that. This has been such a fascinating exploration of cognitive load theory.
It has.
And I think we've covered a lot of ground here.
We have.
So to wrap things up, let's take a step back and reflect on what we've learned.
Sounds good. So we've really gone deep into this whole idea of cognitive load, how it works, how it impacts our ability to learn, and more importantly, how we can use this knowledge to make learning more effective.
It's been a fascinating journey for sure.
It really has, but now I'm curious. How can our listeners actually apply all of this in their own lives? What are the key takeaways?
That's the million-dollar question, right? Like, we can talk about all this theory,
Yeah.
but how do we actually make it work for us?
Right.
Well, I think one of the most powerful things about understanding CLT is that it gives us a framework for becoming more conscious and intentional learners. Like,
Mhm.
we can actually start to recognize when we're experiencing cognitive overload and
Yeah,
take steps to manage it. So
exactly. Yeah.
instead of just feeling overwhelmed and frustrated,
Right.
we can understand why we're struggling and then find strategies to make learning easier.
Absolutely. It's like having this new lens
Yeah.
through which
Yep.
to view the learning process.
I like that. And it goes beyond just our personal learning too, right? Like,
Yeah.
CLT has implications for how we communicate and share knowledge with others.
Oh, absolutely. Think about it. Better presentations, more effective training programs, even just clear communication in everyday conversations.
Yeah.
All of this is within reach when you understand these principles.
That's pretty amazing.
Yeah.
So just by understanding how our brains process information, we can actually make a real difference in how we learn and how we teach.
Exactly. By being mindful of cognitive load,
Mhm.
you can create space for understanding, for connection,
Mm.
and for truly meaningful learning to occur. And it's not just about making things easier, it's about making them better.
I love that. Now, before we wrap things up, I want to leave our listeners with a little challenge.
Okay, I like it.
I want you to think about something you're trying to learn right now, or maybe something you're trying to teach someone else. It could be anything.
Mm-hmm.
A new language, a musical instrument, a technical skill, you name it.
Anything at all.
Yeah. Now ask yourself, how can you apply the principles of cognitive load theory to make that learning experience more effective, more enjoyable?
Right. Could you break down that complex information into smaller chunks? Could you integrate text and visuals more effectively? Could you use worked examples to make the process less intimidating?
Right. And as you start to feel more comfortable with the material, how can you gradually remove that support and encourage yourself or others to apply that knowledge in new and challenging ways?
These are the kinds of questions CLT invites us to ask.
Yeah.
And by exploring them, I think we can all become more effective learners and teachers.
Absolutely. So keep those cognitive loads in check, everyone, and happy learning.
Happy learning.
And be sure to check out the show notes for links to the sources we discussed today. Until next time, deep divers.